Well, hello friends. Welcome back to browser hacking. Today we are going to continue with the stuff that we worked on yesterday. So the resource loader stuff. And yesterday we made it so that resources are shared between downloads. So basically, if you have many IMG tags in the browser and they all point to the same URL, then we only download that URL once and then share the downloaded data between all the image elements. Now today we're going to take it one step further and also share the decoded data. So currently we decode each of those images separately, even though they're the same data. We downloaded the same data, but we'll still decode it into a bunch of separate bitmaps, basically. So today we are going to build on the stuff from yesterday and then add a way for a resource to also have decoded data in addition to its encoded data. So because resources come in a few different types, right? So you have the typical web resources are HTML content, JavaScript, images, style sheets. Those are like the main things, and then there are various other things like you can XHR and get some JSON and whatever. But today we're going to focus on the image type. But all of those types, though, they have different decoded forms. So it's not really possible to say that like, oh, this one decoded form works for all resources. So for that reason, we're going to subclass resource. So we'll make it virtual. And then we'll have I think we'll just call it like image resource, like this. And this will be a resource, but we know it to be an image, right? So it can have, I guess, an image decoder. So image decoder, right, and what do we need here? I guess we'll have an API that just gets the decoder for you. So we'll have ensure decoder. It will always return a decoder, so we'll instantiate it if necessary. Okay. And then we need a constructor, so image resource. So it will be the same as resource, which takes a const load request. So same type of constructor here. And I guess we'll have a virtual destructor. And then we'll have to make this protected. And also, I guess we're going to need a type. So we'll have a type thingy. And we can have a couple of different types we can define here. So we'll have a generic type. So that's like, it's only encoded data, basically. And then if we know some better form that we can decode into, then we'll have an image type. And maybe we'll have, some other types here, like style sheet, script, or JavaScript. Although we don't need to put those in now, but so with the image, what we'll do is we'll just decode it into a bitmap. But then if this were a style sheet, for example, we could parse the style sheet and then cache that with the resource, because if, for example, if you're on one page and you click on a link to go somewhere else on the same website, then it's super duper common that two pages on the same website refer to the same style sheet. And if we can get that resource, the style sheet resource out of our resource cache, that means we can also avoid parsing it if we already have it parsed in memory anyway. So that's a good trick for making page navigations on the same site much, much faster, because you can avoid a lot of the parsing work as well. So anyway, I'm really getting ahead of myself. So let's focus on images instead today. So maybe the create API will take a type, and Yeah, let's do that. And then resource loader is the only one who calls this anyway. So you can call it with resource type. Or maybe we should pass the type to this API. Load resource. We'll do it this way. Resource type. Yeah, that's good. And then here, we will just make sure that we take a resource type. And I guess we'll need to actually grab resource at this point so we can see that enum. But that's, or wait, oh no, this is fine. This is fine. I was thinking we could put that argument last and have a default value, but at the same time, I'm not sure that's useful at the moment. So we'll just resource type generic. Yeah, so we'll just pass generic as the resource type, and then when we once we get images working nicely, then we can move on and do style sheets and scripts and so on and decode them into their various interesting forms. Okay, so we don't have that many clients of this API. Since last video, I just made the link element client of the load resource API and the CSS image style value. So if you have like a background image CSS value, for example, then it will now load that background image through the new load resource API. Anyway, so this was just adding a type, and then now that we know the type, I guess in this function right here, resource create, we'll have to branch on the type basically. So if type is type image, then instead of a resource, we'll give you a new image resource for the request. And I guess, oh, this thing here is going to have to take type. Where does this go? Here, maybe. We'll just start it out in generic. Okay, so if type is image, then do that. Otherwise, just make one with type. And this is private. Okay, so here we're just going to make him a friend so that resource can create an image resource. That's fine. Okay, so now we have image resource, and how do we make use of this now? I guess we'll do it in the HTML image element. So here, when we call load resource, we're going to pass image instead. And that will cause us to call set resource, which is a member of resource client. Oh, I know what we'll do. So then instead of HTML image element inheriting from resource client, we'll make it an image resource client. And then we'll also have an image resource client subclass of resource client, where we can add additional stuff that's only relevant to resource clients that refer to image resources. So resource client, final. Oh, no, it can't be final. You're supposed to inherit this. So let's see. One thing here is that unlike these functions right here, resource functions, they should be casting. So we should cast to image resource because we know that the resource is going to be an image resource. So we'll just static cast to image resource. Oh, I can't do m resource. I have to do resource client resource. All right. Okay, so there is our little convenient thing. Okay, so now in let's see, so in image element, when we get resource did load, so now we have the encoded data, then instead of the image element having an image decoder like this, that's reference counted. So what we could do instead is we can just say resource ensure decoder, and then we will just make a reference pointer to the decoder in the resource, which will then be shared with everybody else who downloaded the same resource. And actually, this should have the curious side effect that animated GIFs, like if you have the same animated GIF occurring multiple times in a document, then they will be synchronized because they all use the same image decoder. So that'll be cool. Well, that's probably the responsible thing to do anyway, because then that allows you to minimize the number of frames that you keep in memory at any time. If you wanted to do that, because I remember working on, there was an issue with the google.com front page like years ago in macOS Safari that it was using like you would go to google.com and it was using like 1.5 gigs of memory for the Safari process, and it was because of a GIF animation that they had. They had like this, I don't know, like 800 by 800 pixel GIF animation with tons of frames, and we would just load them all into memory and just iterate through them, and that was not very good. Anyway, I'm totally spacing out thinking about something else, so let's get back to work. So ensure decoder, we need that to actually do something, so let's see about implementing that. Maybe this should be in a separate file actually. I don't know why I started putting it in resource.h. Let's make image resource.h and CPP. Oops, I meant to edit that, not just touch it. So resource loader, where are you? Here. Okay, so image resource, and then we'll just grab all of the image resource parts here. So this stuff, pragma unse, namespace web, image resource, you go right here, bro. Don't even worry about it. And likewise with the include, we'll do that, and we'll move this guy over here as well. And then only the code that cares about image resource and image resource client needs to see those classes. I think that's fine. Great. Image resource CPP. Oopsie doopsie, that's very large. So let's see what we can implement here. First, the very uninteresting destructor. Finished. And then ensure decoder, which needs to basically make sure that our decoder is non-null. So if it is null, then image decoder, we need to include something for that. Image decoder, oopsie, create with a byte buffer, so the encoded data. And then we'll just return it. And then we have the constructor of image resource, which really just needs to forward to the constructor of resource. So type image and give him the request as well. I think we'll put that up top. It'll be a little nicer. Just a nice little bush up there. Okay. And for the image resource client, we'll have the, again, very uninteresting Destructor. And I think we are at a good place. So let's see if this works at all. Now, where are we now? Image resource client. Expected class name before token. Well, it seems like HTML image element needs to include the newly minted image resource.h. So this work that we're doing now, it destroys our purgeable memory optimization that we do for images, and we're going to need to fix that. So I'll talk about that in a moment. Image decoder does not see bitmap. Wait, and we are actually calling through the bitmap on 39. Oh, we have a destructor of this thing. Who has these? Oh, it's this right here. Well, do I want to change the header? Or I can also just be a lazy boy and get bitmap manually here. So the purgeable thing is all the images that we decode are purgeable memory, and then we manage their volatility flag based on their position in relation to the visible viewport. So basically, when an image on a web page is in any way visible to you, like because it's like you've scrolled to a part of the page that has that image in it somehow, then we make sure that that image stays in memory. But the moment you scroll away from that image and not a single pixel of it is on screen, we tell the kernel, hey, I'm not using this image, so you can take that memory if you really need it. And that's a really cool optimization that tends to work really, really well for managing memory pressure. And we definitely want to keep that optimization. And now we're kind of breaking that because that it's built in a way that assumes a one-to-one relationship between an image element and a decoded image. So now we'll have, I hope, yeah, okay, so here we go. So this web page here, the mini test, which let's bring up the source code. So this one is the one we made yesterday. And it just has these 5 buggy PNGs, but now we actually download them only once, and not only that, but we also decode it only once, which is pretty awesome. And let's see if we can see that in the, oh, stop jumping away from me, you jerk. Okay. What do I want to look at? I guess I want to look for name. Decoded PNGs. These are all the toolbar icons and stuff. Decoded PNG. Oh wait, maybe we don't say decoded PNG for anything like that. So what do we have here? Oh, these are all different ones. Okay, so we're not doing it right quite yet. Bitmap. They are clearly different allocations. They have different virtual addresses. Okay, so we got to do something about that. How does that happen? Let's see. So HTML image element. Ensure decoder. Okay, and then if there's no decoder, then do this. Okay. So let's log something here like this. Decoder is image decoder putter. Okay, so this now we'll just log the image element pointer and what his decoder pointer is, because we just want to make sure that we have the same exact decoder for all of them at least. So decoder is all the same. That's really good. And then so then what happens, what we call bitmap. So when we call bitmap on the image element, then we call bitmap here. So let me, oops. I'll say this bitmap is bitmap putter. I just want to find out what we think the bitmap is. Oh, and dot putter. Yeah, no, that's fine. Okay. Okay, so there's one bitmap here. Does it change if we go down? I feel like there are two different ones. So, two images, okay. They should really only have one. So let's figure out why that's happening. When we call bitmap, then we will ask the plugin for the bitmap. Okay, and every image decoder has a plugin inside of it, if it's a valid decoder, and the plugin just implements the specific file format that we're using. So currently we have a PNG plugin and a GIF plugin. And in this case, it's going to be a PNG image decoder plugin that we're talking to, since these are PNG images. So we call bitmap on it, which is here, PNG loader, bitmap. So basically, it will make sure that the PNG has been decoded, and then it will return the bitmap. But it is kind of interesting that the same decoder would have different bitmaps. Well, why would that happen? We should probably log what the decoder is when we do this so that we can see image decoder. Okay, I just want to see if they're the same. Yeah, that's what we want to see. Okay, this is not the most readable, but so this is one decoder and one other decoder. So we have two different decoders, and we have this guy here and this guy here. So I wonder if we're just messing something up with like the first load, and the first load succeeds, but it doesn't cache its decoder in time or something. But they should be the same resource. Oh, wait. Maybe the image can actually drop his resource. or rather drop his decoder. Let's look into that. HTML, oh, we are here already. Image decoder equal so resource did load. We'll set the decoder. Sure. Let's assert that we don't already have a decoder here. Resource did fail. That will clear the decoder. So here we should never fail. So we'll say assert not reached just for this session. And then set volatile, and we'll do this. So let's assert not reached. Maybe this is where we're ending up. So this is the purgable optimization that we're gonna have to re-architect anyway. What? Okay, so who killed us? 73. 73. Oh, wait. I should have asserted that I didn't have one. Assertion backwards. Instructions unclear. Or many, please. Okay, now we're at 182. Okay, so there's this guy right here. He overwrites. Oh, and look at the way we overwrite. This is obviously the problem, because here we just overwrite it with a new image decoder that we create, so that we shouldn't be doing that. We should really just be saying like resource ensure decoder. So that should fix that issue. Let's just verify that we end up with a single instance of an image this size in our memory map. So system monitor, browser, and then it's so jumpy. Why are you so jumpy, dude? Wait, this resize here doesn't work? Did we break this? Okay. This is surprising. Wait, has this been broken for a while? This works. Okay. But if I put this thing here, it still works. Okay. So I don't know how I managed to break the thing. But maybe Splitter needs a little bit of work. Anyway. So let's sort by name. And then we'll look for the graphics bitmap. So this guy right here is the only huge 455 by 1000 bitmap in the process. So we've gone from 5 of these down to a single one. And we're fetching the pixels from the same bitmap, even though we have 5 copies of it. So everything is as it should be. That's great. But the purgable thing is no good, because the way that it works now is that whenever we scroll the page, then a notification is sent to the page, and it will go through all of the images in the page and look, hey, is this particular image in the viewport? And if it is, or rather if it isn't, then it will inform that image, hey, you can now make your purgable memory allocation volatile so that the kernel can take it if it wants. But it does that. We get called here set volatile. And what we do is we just call through to the image decoder. But since this is shared, this means that if any image that shares the decoder is outside of the viewport, we will mark the underlying decoder as volatile. And then actually we'll check again, we'll loop through all of them. So I guess it's the last one that we check determines whether we're volatile or non-volatile, but we really want to take this into account properly. So I think this is where the image resource client API comes in. So we'll do something here. We'll say like virtual bool is in viewport, is visible in viewport. Should we say in viewport? Visible in viewport? is visible in viewport. That's really good, I think. Okay, so this will be a virtual thingy that you can implement, and you will inform the resource somehow about this, and then we'll have an API on image resource, just like update volatility, and this API can call this API on all of its clients and then determine if any of them are in the viewport, and if so, it has to be volatile, or it has to be non-volatile rather. So let's see how that would look if we write it out. Image resource, update volatility for each client. I guess it's like that. And then, wait, what are we gonna say here? Oh, we need, wait, we need act function. I guess we can get that. For each client. If static cast const image resource client dot is visible in viewport. So if it is, then visible in viewport is true. So something like that. Okay. And then if, or no, hold on, let's see what we do. If not visible in viewport, then decoder set volatile. Return. The volatile case is simple. Set non-volatile is less. It's a little bit less simple because it returns a flag. So it returns has decoded image. Still has decoded image. Because the thing is that when you transition from volatile to non-volatile, then if the kernel has been there and yanked that memory away while you left it as volatile, then we'll learn that once we call set non-volatile. It will tell us, all right, the memory is yours again, but while you were not using it, I took the whole thing. So whatever was in there, you gotta reconstitute that. So here, if we still have the decoded image, we're good. Otherwise, we have to re-decode the image. But that's okay, because we have the encoded data. So what we'll do is we'll say decoder, maybe redecode. So this API will be a little awkward, but we're kind of, it's a little bit awkward now because we already have image elements that point to our decoder. So the API as it is right now is image decoder. You create an image decoder and you provide the data, but then the decoder doesn't hold on to the encoded form. The data that you provide to the decoder is the encoded data, but the decoder itself will just process that, turn it into a decoded representation, so like a bitmap. And then it doesn't care about the encoded data. So now if we want to redecode, we have to supply data again, which feels really awkward because the decoder kind of, the decoder has like an established width, height, format, animation, frame, state, whatever. And it does feel weird to just have an API where you would do basically this, right? We decode, or essentially by buffer, like that, right? Because you could imagine like calling that with some other data that does not match the stuff that you passed to the constructor originally. And then things get confusing. But the issue now is that in HTML image element, for example, we have a pointer, a ref footer to image decoder. So we can't just replace it because all the image elements will still be pointing to the old one. Unless we have a resource client, image resource client API that sort of retargets it. So I would say something like virtual void decoded replace decoder or something like that. Resource did replace decoder. And then if you are using the decoder, then you can go and pick that up. I guess we could do something like this, because then we don't have to add the awkward API to image decoder. Yeah, okay, let's try this. So resource did replace decoder, and then an image element, we will have that, so virtual void. And if this API gets called, okay. So what are we going to do then? Then all that we really need to do is just say image decoder is resource ensure decoder. That's all there is to it, really. And then that will cause us to let go of this decoder. And it will disappear, which is fine because it doesn't, we don't have anything important in there anyway. Maybe we have like the animation state. So if you have a GIF that's like outside of the viewport, and then the kernel comes under memory pressure, so it will reclaim the memory in that GIF, and then once you scroll it back in, like the animation will start over. But I feel like that's not a super important scenario to complicate the design over. So let's not do that. Okay, so we can get rid of that. Yes, this is pretty sane, I think. All right, so then how do we learn about this stuff? Is visible in viewport? That needs to actually report something, so we need to have that in image element. We should say, sometimes I put these little things so that you can see where some overridden things belong to, where they come from. I like the way that it looks, but I just always forget to do it. So anyway, maybe this thing will just return a flag visible in viewport that we will keep track of. So we'll have something like that. And instead of set volatile, we'll have set visible in viewport. Yeah, that's pretty good. And then that's a bool reversal, so let's just keep that in mind. So the set volatile logic we can just get rid of. Okay, and then where we iterate over all of the documents. So this is where we end up when you scroll the page. Then we call did set viewport rect. This is called by the HTML, the page view widget calls this, informing it like, oh, now you're scrolled to this particular rectangle of page content. So we just iterate the entire layout tree, looking for any layout image, and then we will poke through into the DOM and say this particular DOM node is now in the viewport or not. So that's what we'll do here. Set visible in viewport, and then we just reverse that bool. and I think we're good. Set visible in viewport is viewport rect intersects layout image rect. Yes. Okay, so how can we verify that this works? Oh, wait, this is not going to work. This is not going to work because we never implemented this function right here. It'll be very different from what I deleted here, but set visible in viewport. We need to inform the resource. So here, if m visible in viewport is already the same, then whatever, but otherwise, and resource, if m resource, then resource update volatility. Yeah. Oh, where's that redecode thing I started writing? We're not even going to have that. Redecode. Okay, yeah, so right. So what do we do instead when we update volatility? So instead of redecode here, what we want to do is we want to say mdecoder is essentially just create a new decoder. So we'll throw away the old one and then ensure decoder. Yeah, that works. And then, in fact, we can just throw away the old one and then make the client, we could make the clients drive the instantiation of a new decoder, because client will notify the clients here. So for each client, yeah, it's essentially like this, but what we're going to do is we're going to call and tell them did replace decoder. Like that. And then if any client is interested, then it may ask us for a new decoder, at which point we will instantiate a new decoder, but we don't instantiate one unless somebody asks for it. That's pretty good. Okay, so let's test this out with the menu page. That does not work. Update volatility. Assertion failed, mputter. Okay. Update volatility is poking through into this guy right here, I bet. So if mdecoder, actually update volatility. If you don't have a decoder and you call update volatility, none of this is interesting to us. So it's only interesting if we have a decoder, because this is all about either changing the volatility state of the decoder or throwing away the decoder and making you ask for a new one. Okay, so here we are. And oops, I meant to bring up a system monitor. Can I please get one? Here we go. So here is browser. Actually, I wanted to size it up like that. So where is our big allocation? I guess we can just sort by size. Okay, so this is our huge bitmap, and it's currently non-volatile, as you can see. And what we need to do is we need to bring it outside of the viewport, but we can't really do that because it's occurring all the way down on the page, right? So here, let's see, how do we do this? Yeah, it's always non-volatile because in some way this bitmap is always on screen. But what if we do something like that? It becomes volatile. And that means that it's not, it's still in memory. So if you do this, it's still there. And see, it becomes non-volatile again. But while it's volatile, if we do come under memory pressure, which we can simulate by just running the purge command. So notice here it has 1.8 megabyte resident memory. So if we simulate memory pressure with purge, then boom, all of that memory was taken by the kernel. But if we resize that window, we should transparently make it pop back in. And we do, because we re-decode the thing on demand, and you are none the wiser. And that's the purgeable memory mechanism, and I love it. I feel like I didn't rant and rave about how much I love purgeable memory for a while, so now you get to listen to it. But isn't that neat? Like, if you don't need something, then it's still there, but if the kernel should need more memory, then it'll take it. But if it doesn't, then no big deal. It's still there. Very cool mechanism. Anyway, this is pretty neat. So it actually kind of works, or it totally works. So this is all the same. Very, very good. And just that one. So what did we have before? We had 5 of these. So that's 5x memory usage reduction. Very cool. And of course, now we only decode it once, so that's way less CPU usage. We only download it once, way less network traffic. Cool. I guess I'm very satisfied with this, and you can tell, but I really like the way this is turning out. So let's see, what do we have here? Did I add any obnoxious logging? I feel like maybe I didn't, not today. So let's go ahead and commit. Let me just verify that I have all the good boy copyright headers and stuff. All right, we do. And I guess we can add that mini test to the, maybe we should add it to that repository. Base home and on. But we will put it in www and we'll move it here. So mini becomes mini buggies. And we'll put it in the welcome page as well. Mini buggies. Okay, and let's add that. And now, oops. Let's write a monster commit message. Or just a normal one. So share decoded images between at the resource level. Oops. This patch adds image resource as a subclass. An image resource. This allows us this new class. Also keeps a GFX image decoder so that we can share decoded bitmaps between all clients of an image resource inside the web. With this, now share encoded data, raw file, image file, decoded data, RGBA pixels, and I guess those are the both encoded and decoded data for images. That's so cool. In order to make this I had to change how the Purgable Volatile flag is updated for each to keep volatile images outside the visible viewport optimization. Okay. Images, additional image element now inherits from image resource client a subclass of resource client with additional image specific stuff, and informs the image resource, its image resource about whether it's inside the viewport or outside. Wait, so when did we update volatility? I already forgot when we called this. It's when we do set visible in viewport. I guess that's okay. It'll cause us to do many updates, so maybe we should have a note about that. But let's say this is pretty awesome. Let's see, fix me. Don't update volatility time. Instead, do it only once per resource. If we're here, we're probably scanning through the whole document looking for updating and viewport flags, which could lead, and this could lead to the same bitmap being marked volatile, non-volatile, volatile, back and forth unnecessarily. I mean, actually, the moment that you encounter one, yeah, so this is not, it's not perfect. So we should probably, I don't know, turn that into a 2-pass algorithm or something at some point, but this is good enough for now. So we'll just add that comment in there. All right, well, that's really nice. I mean, I'm still optimistic, like yesterday when I tried to load Twitter and it just wouldn't, but let's try it again today. Oh, wait, that didn't work. And let me try the whole thing. Maybe Twitter will load today. One of these days it's gonna load. One of these days. Come on, Twitter. Look at all those parse errors. Oh, dude, what's that? It's a parser problem. Although, while that is a parser problem, we also have some problem here. I guess we fail a download somehow, and the parser can't deal with that. Maybe we should do... We should definitely do some kind of caching at the... we need to cache like HTML resources as well, obviously. Why do you keep dying now? Well, that was another death in TLS. Okay. I don't know why I'm being so persistent about this. It's clearly not going to load. But I guess I just wanted to see something. I just want to load some random page with some images on it. Here's some images, or at least one. Here's another one. Cool. Here's another one. that's pretty cool too. Alright, well, I'm not complaining. This is really awesome. I'm really happy with the outcome here. Let me just take a quick peek at what we do for link elements. So, link element, what we do is we fire off a style sheet load if the rel is style sheet, and then once we get that downloaded, then we just add it to the document. So we don't hold on to it or anything like that. You could certainly imagine having a style sheet cache here and storing the parse sheet with the resource, but I don't think we'll do that today. I think this is going to be the end of today's video instead. So if you made it this far, then I thank you for watching and for hanging out, because this is super duper fun to me, and I hope that it's interesting to people. I got some really nice comments yesterday, and it's really, I think it's so nice to get to do all of this with people watching and learning together with me as we go, because I worked on WebKit for many years, and I've had a very superficial understanding of how loading works, loading mechanisms, and now like getting to implement them from scratch, it's very, very satisfying for me to like actually take all of that sort of ephemeral or like kind of not very sturdy knowledge and turning it into something very, very concrete. And it's nice to have company while doing that. So thank you for hanging out. And I guess that's it for today. So I'll see you next time. Bye.